Hello everyone. Today I'm just going to introduce you to a system of three equations. We're going to take a look graphically at what this means, as well as just what you see on the screen right here. It's three equations having three variables now, so it is going to be a lot more work. We're not going to get into solving them by hand until tomorrow, but I just want to walk you through this, and we're going to actually go to a website that's going to allow us to kind of interact with the graph here. So again, a system of three equations has three equations, but now we also have a third variable. The solution, instead of it being called an ordered pair, which just contains an x and a y, we call this an ordered triple. And it's going to have three spots here for when we solve for x, solve for y, solve for z. And those are typically the three most common letters we're working with. Now, a solution to a 3 by 3 system must satisfy all three equations of the system, whereas an ordered pair must satisfy two equations, both equations of the system. So what I'd like for you guys to do is open up a new tab. You can copy this down. I'm going to walk you through this as well. But it's a really cool website. It's called intmath.com. It's interactive math. So just type in intmath.com. And let me bring this up. So this is what should come up when you go there. To the left here, we're going to click on matrices and determinants. That's eventually what we're going to talk about, but systems of three equations is hidden under here. So go ahead and click on matrices and determinants. And then the second one down, systems of 3 by 3 equations, interactive applet. Now notice here, it's giving us a sample of a system, an example of a system of three equations. And we're going to scroll down until you see this graph. So this is just one example. I'm going to just show you the other two as well, but all we really need is one. So I'm actually going to deselect what this looks like, and I just want to show you this is now, instead of being just two-dimensional, now we're three-dimensional. So not only do we have the x-axis, we have the y-axis, but it looks like the x-axis is is facing us. The z-axis is now vertical, the y-axis is horizontal, and the z-axis is kind of like our depth. It's coming towards us and then it's going back. But you could rotate this as well, clicking on your mouse pad. I have a little stylus here, so that's what's making it a little bit easier. But yeah, we could switch this if you were to just rotate it so you could kind of see. You could bring the z-axis down almost like you're getting a bird's eye view over it. But this is where a lot of the computer design and animation started with math, with the system of three equations. So now if we go to click on the first box here, now an equation that has three variables no longer graphs a line, it graphs a plane. And then if I click on the second one, here's our second plane. Now two planes intersect for a line, to form a line. If we put a third plane in there, it gets a little messy now, but we could still rotate just to kind of see what this is looking like. We're definitely not going to graph these by hand. We do not want to do that. Now, all three planes, once we get a third plane in there, they're not going to intersect at a line, but their lines that they create are going to intersect at a point. Now, it might be hard to see here, but if you notice this point, as I'm going to rotate, you can see where all three planes intersect. That might be a better view of it. It's going to be at a point. Now, what's nice is we could clear the planes out of the way, just deselect those, and then we have the point. All right, so again, the first value is the x. So if I were to rotate this a little bit better, we could see this is our x-axis now. And I'm right over the 4 on the x-axis. And if I turn this to the y-axis, kind of lining it up here, it all depends on how we have this rotated. But this -3, if you notice this point is over -3 on the y-axis, and then it's up to 3 on the z-axis. So again, we're three-dimensional here. But the way we go to turn it, it might be hard to line it up. But again, you could kind of play around with this. And the same thing would be true of the second system. We could hit the intersection point there, deselect the first one, and it kind of shows you that point is just floating there in three-dimensional space. So pretty cool idea now with a system of three equations. All right, so like I said, I just wanted to introduce you to this, what your assignment is today. And this is actually, before I get to that, I did this on the Inspire the handheld calculator. So it just shows you as well. Now, I can't do this here, but I just captured the image. The example I had at the beginning, to use the Inspire, we would have to type this in and solve each one for z. So it's a little bit more work. But again, you could see 3 planes intersecting. Now, if I actually gave you the Inspire, you would be able to rotate it just like we did on that interactive app. All right, so I'm giving you guys another graded assignment today. It's another 10 points. It's 10 problems, so each problem is worth a point. Feel free to look back in your notes on this. It's going back over the commonly missed problems from the last quiz. So I still want to give you guys more time to work on factoring. Feel free, especially for my remote students, email me if you have any questions. So that's the attached PDF. So like I said, tomorrow and Wednesday, we will be starting to solve a system of 3 equations by hand. On Thursday, I'm going to give you guys the final grade of the grade period, another graded assignment over systems that we've been working with so far. And then don't forget your homework grade is also going to go in. So quite a few grades are going to be put in, collected and calculated this week. All right, so take care, guys. Let me know if you have any questions.